Hi friends, welcome back to codeindia. This is a Swift basic tutorial, and in this part of the tutorial we are going to discuss scaping and non-scaping closure. Before we start with the scaping and non-scaping, let us go through the definition of the closure. So what is a closure? A closure is a block of code you can pass around and use elsewhere in your code. This is just like a function you can assign to a variable. You can move a closure around to your code and call it later. This makes a closure exceptionally useful as a completion handler. Saying the completion handler, let us discuss what is a completion handler. A common use of a closure is a completion handler. Most of the time we use this completion handler. So completion handler in Swift is a function that call back when the task completes. This is why it is also called the callback function. Callback function is passed as an argument into another function. When this function completes running a task, it executes a callback function. Callbacks or closure are useful in Swift when dealing with a asynchronous task. For example, an HTTP request takes a while and we need to wait for the response. This is where the callback helps. When an HTTP request finishes, the callback runs a piece of code to show the response. In an asynchronous function, you can start a next task before the previous one completes. This way, you can deal with the multiple requests simultaneously and complete more tasks in a shorter time frame. In Swift, completion handlers are used to run code after a task has been completed. They are commonly used to expose the result of asynchronous callback to the caller. For instance, let us make a HTTP request that retrieves a HTML content of any page. As this request takes a while, we need a callback function that shows the HTML content once the HTTP request completes. To retrieve a web page in a Swift, use URL session.shared.data task function. This function takes a URL object as its first argument and a completion handler as a second one. This completion handler function takes the following parameter: data, response, and error. Data is a data returned by the request. Response is the response metadata object that includes the HTTP header and the status code. Error is the error object that with information about which the request failed. It returns nil if the request was successful. To show the HTML content, you need to define a completion handler with this. The URL session shared.data task function then calls it with the data, response, and error it got from the URL. Notice how the completion handler function is defined directly into URL session.shared.data task. However, you can also define a separate completion handler function too. But this usually is more unconventional way to use callback, even though it is possible. Let us discuss the syntax of the closure. See, this is a simple syntax of a closure. Curly braces with a parameter and a return type and a statement. So, we write the parameter and the return type and the statement. Example is the sorted higher order function, sorted function, where we are sorting the names array, and the names array have been sorted using this S1 is less than S1 is greater than S2 condition. So this is the simple example of the closure. So let us discuss what is a scaping and non-scaping closure. A closure is said to scape a function when the closure is passed as an argument to the function, but it is called after the function returns. When you declare a function that takes a closure as one of its parameter, you can write @scaping before the parameter's type to indicate that the closure is allowed to scape. In Swift, closures are non-scaping by default. For a non-scaping closure is a closure that is called within the function it is passed into, that is before it returned. This closure never passes the bound of the function it was passed into. Why we use a scaping closure? A scaping closure can cause a strong reference cycle if you use self inside the closure. Safety feature like non-default, explicit @scaping are built into the Swift programming language. So you can remind yourself to check if you haven't caused a retain cycle accidentally. So this is a use of @scaping keyword. It reminds you that you are creating a strong reference. When that scaping closure reference self or a strongly retained property, it will capture that reference strongly. If the scaping closure isn't properly released, you have created a strong reference cycle between the self and the closure. It is not possible to create a strong reference cycle with a closure that is non-scaping, because that closure doesn't outlive the function it was passed into. The closure is released by the end of the function, and so are the values it captured. Scaping closures work differently inside the struct and classes. A scaping closure passed into a struct function cannot capture a multiple reference to self. Because the struct are value type, you cannot change the struct outside a function marked with mutating, but only inside it. It is not that @scaping avoid the strong reference cycle. It just makes your code more explicit. It increases the safety of your code. It is just like a optional which decreases the likelihood of accidentally creating bug. Scaping closure have an inherent risk, a strong reference cycle. This happens when the closure strongly holds onto a reference like self, and a closure itself is also retained. You can avoid a strong reference cycle by using a capture list like weak self. Bracket, inside this bracket we use a weak self to avoid a strong reference cycle for a scaping closure. So with this we have come to the end of this part of the tutorial. In our next tutorial we will deal with all the example of scaping and non-scaping closure, and the scaping and the non-scaping closure will become more clear to you in our part 2 of the tutorial. So hope you like this video. Don't forget to like and subscribe this channel. Thank you for watching. Goodbye for now. See you in our next tutorial.